Okay, so we left it basically here. That's what I was trying to figure out is why why is these basically flat, right? Because if I do Python train.py, it just basically runs it flat. So okay, function for grad. The grad is here. This objective function is like this. It's using self values. It's all fine, as we saw in the examples. Returning this stuff, it's also all good. Wiper is here. Self logits. So why? So the question is why can it be flat? So how can we explore grad W2? Can I print this? Can I serialize? Can I serialize? Can I print the result, the function that I'm calling grad from the autograd package? So certainly function print function. That's just gonna. I think that's not gonna work because I think that is just gonna print whatever object or something. I would need to probably serialize that or something. So, but we can try print these and then see what happens. Function, yeah. That's doesn't print. I want to see the. I wanna see what it returns. Okay, that just prints like. I want to see. I want to understand how it looks like, so I can debug why the loss, why the derivative, why it evaluates to almost 0 every time. This is what I want to do. So the memory address, yeah. My function, print grading function. That's not the point. For different values of x, yeah, but that's kind of like it's defeating the purpose here, because I mean I can try something. I can generate some random values of these. I can try a few things. So I can try basically multiple so I can just try multiple things like this. See if that does anything. Input size. Can I just input size? So can I just say self hidden size equals hidden size self input size self input size? Yeah, so at least we have these two things in here, and then we can just self and self, and then essentially so Python one-liner loop 5 times. Can you give me this? Just like that. Sorry guys. Okay. So we'll do it like this, and then we'll just let it run. Let's just look at so what do we have here? A few things, right? They're all very small. They're always very small. They're always very close to 0. It doesn't matter what I give it randomly, right? They're always very, very close to 0. I just don't understand why. Maybe like why is it printing the function? That's not why. I'm not telling it to print the function. So how else can I function? Like how else can this do? Like that's the dot. That's kind of where it's used, right? It's the dot product of these. So anything else I can do is simplify that. Dot. So grad. maybe this is just not working well. I don't know. NP, maybe. But this is autograd numpy, so I'm using the autograd numpy. So do I need to consider anything special when using autograd grad with a parameter that's an NP array, right? Kind of that's the thing, because essentially that's what's going on here, right? So the parm w2 is just an NP thing, right? But the problem here is maybe I need to declare this somehow, because maybe it assumes it's something else, because I'm not like, you know what I mean? Maybe let me try one thing. What happens if I just do like these. Is it gonna break? Because that's the problem, right? I think that might be one of the reasons this is not working, actually. How does this even know? Is this gonna break at all? Mm-hmm. Okay, yeah. So it does actually infer some sort of somehow the type. Can differentiate with regards to these, okay. NRE op core. So it does keep that into account, as in at least what's kind of usable here, but maybe not. Maybe there is some nuance in there. So type compatibility, array type, autocorrect numpy function definitions, or defining function from which you want to compute the gradient, ensure that it can handle autocorrect numpy arrays. This means you need to replace import numpy SMP with import autocorrect. Yeah, that's we've done these. You'll specify the function and the variables with respect to which you want the derivative. Make sure the variables are compatible as described. So NP array, func like these. That's NP array. Convert a standard numpy array to autocorrect. Unless there's something wrong here because of these things being defined. No, they're being defined all here contained. There's nothing that comes from the train loop other than, indeed, other than when I'm calling backward, I'm sending the distribution and the output. These things are then stored. That's why I should have everything at once. These things then get stored. Self X and self Y true. Maybe that is the reason. So maybe we should just change that here as well. And go ahead and run it again. Maybe that's the reason. Because otherwise I am not so sure I would figure out here what's going on, right? Then maybe what I should do to just, because if that doesn't work at this point, I think out of removing variables from the equation, should probably just merge everything into one file and then see what happens. And I should probably open the output already, see what is that going to give me. And yeah, I think so. I guess we would kind of want to probably merge both things, and then at least we know that everything is essentially the train function. The training loop makes sense that it's inside the network object as well. I don't know. Maybe it doesn't make any sense, but you know, whatever. So at least we know this. Okay, so at least we know this. The thing is, yeah, I guess the optimizers then. I'm just trying to think ahead about the optimizer element, but the optimizer is what we will then basically replace this whole loop with, because it optimizes the parameters, and that's my guess. That's what the training loop would do. Optimizer. Tell me a bit more about optimizers and epochs. Tell me. Epochs. I bet suited to what loss functions. It's fucking flat still. that's just flat. I just can't get it to work, and it bothers me a lot. Adam. Okay. It still doesn't work. Even after switching NP to the autograd NP stuff. Because I thought maybe the fact that this was calculating, you know, NP zeros and whatnot, and this kind of stuff like this, right? Because that's what we then pass here, and then the same as x1 being x, because this is the stuff that then happens there, right? So what else am I doing wrong? What else am I doing wrong? It's the loss function. The loss function. True white bread. What am I doing wrong here? What am I doing wrong? Why? I need to take a look at X. Yeah, it just needs to look at everything, right? Yes and no, right? Yes, of course, because even here at some point you have X, right, to propagate the W errors. But why isn't this working? So it's parameter W2. And again, this is not so much about fixing a bug. It's really about, according to my intuition, it should work. So why isn't it working? It's either because of bug or it's because there's a flaw in my understanding, right? That is what worries me more. The second type is what concerns me a bit more. South B2, there's nothing here that would say, like, because it needs A1. I mean, is it just, could we just try something else? I will try this. I'll just try something a little crazy, right? So why don't we just say self logits? I need some sort of dot product, otherwise it's just not gonna match. No, why? I wanted to kind of modify these, but it's like, I don't know why it's not working. Can you tell me, like, when AI would actually be helpful? Can you tell me why the grad of this function is always around 0? Let's see if it tells me something useful. Saturate, okay, some interesting. Saturated activation function can saturate outputs near -1 or 1. Okay, that is actually useful, you know. It can saturate. Okay, softmax and probabilities. Maybe it has to be done without the softmax. Maybe you're right. Poor initialization, that's just random stuff. The learning rate too high, too low, that's not the problem. Output saturation. Let's try just two things and then we'll call it there. Let's try the following. So let's just let's not use softmax. Okay, let's say that's one thing to try. We don't use softmax. See if that actually changes. And the next one we'll try is runtime warning. Okay. So that's one thing we can try, and then the tangent thing. The thing is, softmax is to basically get those probabilities, right? So but I always thought these things kind of matter, right? I always thought, but isn't of the loss function. I mean, we maybe that's where my understanding is flawed. We have a forward pass, but softmax is basically just some sort of normalization step, and whatever. Maybe softmax is something that you don't really need to derive for. Yes. If not handled carefully, what does this even mean? I mean, okay, that could be interesting. Avoid saturation. Okay. I mean, there's a bunch of good advice. That's definitely interesting for someone even like kind of noob like me, right? Yay! Look at these. Okay. Interesting. So there is actually, okay. Can we do now? Can we use? So what happens if I do that? So indeed, it's really just okay. I'm gonna do these and then I'm gonna wrap it up for today. But definitely, you know, it's definitely interesting advice. So avoid saturation. So basically, those functions that kind of do this normalization stuff, or that not normalization, but the kind of like squeeze the values, are things that you have to be kind of careful with, I guess. Can I visualize the derivative of these? Yeah, okay, I see. The derivative of these is actually pretty much yeah. I mean, it is something that is very, I don't know if that makes sense, but like centered around zero. This kind of stuff like this definitely I can see how it can saturate, I guess. Okay, let's see. For Epic 3. I should probably still anyway merge things, and this should be plus them, not a minus. So here is okay, but that'll just change the. What? Okay, that is interesting. What the fuck? What is these? There's some problems in here. Invalid encounter multiply a lambda. But all I've done is apply this tan x, tan h, the the tangent thing. Why would this create such a problem? Okay, but there's definitely 2 avenues to explore in the next video to try to understand more what's going on here. So softmax is one and tanh is the other one. Okay, we made some progress.